So, hello. Um, we are going to continue with our class on physics, and we spoke about electrical system, which include the charge bodies creation. I mean the electric field, and we spoke about Ohm's law. Electrostatic. That is Coulomb's law of electrostatic, and also we spoke about resistance and their arrangement. Okay, so we have many more to talk about, especially on the electronic system. But before then, we need to look at electrical power because we have discussed the electrical energy. Don't forget, recall the electrical energy or the potential difference equals energy over charge. So, which I said this energy is same thing as work done. So, which means we can have E equals to QV. So, in that wise, this is what we derived, and we derived so much more from that in the previous class. So then we still have more to talk about as far as that is concerned. We have more to talk about. So we have the electrical power. Electrical power. So what is electrical power? If you say power, so power is just like the electrical energy over time. That was the electrical work done over time. So don't forget, work done and energy, they are the same thing. Okay, so power is the same as the energy over time. That is the electrical energy or the electrical work done over time, so which you can define as the rate of energy, the rate at which energy is being dissipated in an electrical system is what we regard to as the power. Okay, so if that is the case, all I just need to do here is to show you all possible formulas you could encounter when it comes to power. So we can have P equals, don't forget this is QV over T. So if we take this as 1, so we can also derive P equals, don't forget this is IT. So then with V over T, so we can actually cancel this. So power is same thing as IV, that's 2. Okay, so we have that. Then if you have to substitute the values of the others, like from Ohm's law, where you have V equals IR. Okay, so if you have to put that here, I think you'll be having V equals IR, so I will be what? V over R. So we can put that this high here as V over R multiplied by V. So I think that will give us a P equals V squared over R. So these are the various formulas you could get for power. Okay, so we can call this 3. So you can get as many more as possible. Okay, so now that is what electrical power is. So that will make us we solve more questions on it in class. So that will make us dive into what is called the electronic system. So the electronic system, we just have to differentiate it from what is called the electrical system. Okay, so when we say electronic system, what does electronic system means? So when you hear the word electronics, it has to do with the behavior of electrons. So what does the behavior of electrons, what does it cause, what does it bring about when we talk about the electronic system? So, and the electrical, don't forget, the electrical system requires a conductor. Meanwhile, semiconductor is much more important in electronic system. So those are the differences. So we are going to look at what electronic system means. So the electronic system is a system that has just 3 levels. So we have the input level, then we have, after the input level, we have the processing. the processing level, and after the processing we have the output. So these are the three levels of an electronic system. So I'll give an example of that. Take for instance your radio station, I mean your radio. So your radio have an area. So the area will be we capture information in form of waves, and then that information from the area captured in form of wave will be sent into the processing. So there we have the aerial. So the area send this information to the processing. So the processing system consists of the tuner. We also have the amplifier and decoder. Okay, decoder and amplifier. Sorry, an amplifier. So this is the processing system. So then this will now be sent to output, which is the loudspeaker. The loudspeaker. So from the loudspeaker, we could get the information that is captured from the area. So this is a typical example of an electronic system. So then we need to talk about so many things in the electronic system. We can also explain certain things that has to do with them. So terms and symbols of those terms, okay? But before we go into that, um, when you asked about the input system, what you would say is that the input system is one that changes another form of energy. Don't forget I told you, for instance, the radio, it takes the wave energy um, and transmit it into another form of energy, which is actually electrical. So then this electrical energy is then used in the processing or the process. That's the changing the input to the required output. So the processing is just like to convert the input into the required output. So then the output is the changing of the electrical into the required energy. Take for instance the radio. So this takes in um, information in form of energy wave. So then this process the information. Don't forget the information is converted to electrical. So then from electrical it is transmitted into sound, which is loudspeaker. So that is how the electronic system works. So we are going to consider what the use of. You can verify with an experiment of LDR, that is light diode resistance. So we call that um, LD R. So it's light diode resistance. So we want to consider how the resistance of this LDR could affect the brightness of light. Don't forget that the diode is a device. Okay, let me give an example of that. So a diode, the symbol for diode is actually this. So this is the symbol for diode. So a light emitting diode, that is LED, we have this as its symbol showing that it emits light. So this is LED. So just for ordinary diode you have this. So this is diode. Now when you have a light diode resistance, so we are talking about a resistor actually. So I want to look at the variance in the resistance of such resistor compared to the emitted ray of light. Okay, so that's where we're going now. I will also like to identify symbols for devices in electronics. So whenever you see something like this, it represents a bulb, B-U-L-B, bulb. And what is the function of a bulb? It turns electrical energy into light. it turns electrical energy into light. Then we have diode. I think I've told you about diode. So diode also turns electrical energy into light. So we have light emitting diode, that is LED. So the symbol for diode is this. I think I drew it the other time. So this is a diode, light emitting diode rather. So LED. Then we have a switch. Switch. When we say switch, switch is like this. So this is a switch, or you call it key. So it is used to start or stop current flow in an electronic circuit. Then we have resistor. And what's the function of resistor? It limits current in the circuit. So when you say resistor, resistor is a device represented like this, or like this, or like this. So what is the function? It limits the current flow in the circuit. So let's take for instance that these ones are conductors. So by the time they get to the resistor, the current seems to move slowly before going. Okay, so that is the resistor. Then we have the ammeter. The ammeter is A, and it's used for measuring current. So then we have voltmeter too, that's V, for measuring potential difference or voltage. Then we have these as a capacitor. Capacitor is just like two metallic plates with a certain distance between them, and it is used for storage of charges in an electronic system. So those are the devices that we would be using here. We would need to talk about them. Okay. So when we talk about those devices, we were talking about LDR the other time. So for LDR, when the lower, I mean, whenever you have a current or voltage goes higher, so whenever the voltage goes higher, the resistance of an LDR goes lower, because voltage going higher indicates brightness of the light produced by LDR. So then, which means we call it LURD. LURD. That is when the lightness goes up, the resistance goes down. So that's it. So that's for LDR. Then there is a device called thermistor. Thermistor. So thermistor is also like a resistor that uses heat, just like LDR. LDR is light diode resistance, while this one is for heat. So heat resistor. Are you getting it now? So for heat resistor, it is TURT. Okay. So which means what happens when you have a thermistor? So which means the thermistor is for heat. So when the temperature goes up, the resistance of the thermistor goes down. So those are the things you need to know. Then we have a device, we can create a device, they call it a voltage divider. So a voltage divider will consist of a cell that produces current. Don't forget, when we discuss the resistors in series, we said they have the same current flowing through them. So if this one is R1, so then we have another resistor connected here. So we have R2. Okay, so now let's connect different voltmeter along the two resistor. So you would see V1, you would see that they will measure different resistance, different potential difference rather. Since they are in series, they have a different uh, potential difference but the same current. So this setup can be called a voltage divider. Voltage divider, because we believe that the voltage from the cell V, that's from this supply voltage from the source, will be divided into two voltage. So and the total voltage here will be the sum of these two. So and there is a relation that shows that V1 over V2 equals to R1 over R2. Okay, so that is the formula for the voltage divider. V1 over V2 equals R1 over R2, in case you might come across question that we make use of this. So then the sensing circuit, when you say sensing circuit, the sensing circuit is circuit that will be able to detect the one thing or the other. That is the case of LDR and the thermistor. Okay, they are both sensing circuit, including capacitor, because capacitor could help you store charges, so you could know the amount of charges in a circuit. Then we have okay, I think I've talked about the switch. So those are the devices and what we need to talk about it. So in the next slide of class, in the video, we'll be looking at what a transistor is and some other things that has to do with transistor, the NPN transistor, and field, what is called the MOSFET, and so on. So we discussed that, what is called sensor, and every other things we need to know, the low temperature sensor, high temperature sensor. Then I've discussed electrical power, so that should not be a problem for us. So then the equations of power, I think I have also mentioned that as well. So we're gonna meet in class to solve more questions on power. So in the next class, we just talk about the transistor, the and the rest that I've mentioned. So that's it.